All right, so this is the first page of our note sheet. We're talking about quadratic functions. Now, a quadratic function can be written, this is it for our first blank. We can write it like, I'm going to write it two ways. F of x, using our function notation, f of x equals ax squared plus bx plus c. So anytime we can write a function like this, it is a quadratic function. And the other way I'm going to write this, just as a reminder, it can be y equals ax squared plus bx plus c. These two things mean the same thing. F of x and y usually are the same thing. So when we write it like this, with x squared first, x second, and just a plain number third, we're going in order, exponents highest to lowest, like we talked about last chapter. This is called the standard form. So when we're writing a quadratic in standard form, it means write it like this. The simplest quadratic function is y equals x squared. That's our simplest quadratic function. In Chapter 9, and in general, you'll see this if you go on to Algebra 2 or pre-calc as well, we call this the parent function. Y equals x squared is the parent function for quadratic functions. And we call it that because we can look at how y equals x squared, the graph of y equals x squared behaves, what it looks like, and we can figure out then what all of these other quadratic functions look like based on what y equals x squared is doing. So we can think of y equals x squared as a parent and all the others as the children of y equals x squared, because they all have similar characteristics. The graph of a quadratic function, we might know this already. The graph of a quadratic function is a U-shape. And we call this U-shaped graph a parabola. And we're going to talk a lot about graphs of parabolas in this chapter. So let me grab the next portion of the note sheet. And I'm going to draw some, well, before we do that, let's go back here. I'm going to draw a couple of pictures here. So just little sketches, you should just make little sketches of these graphs. So y equals x squared looks like this. And I'm going to draw an upside down parabola also, because we'll talk about that in just a second. I could have a parabola that looks like this. So both of those are graphs of quadratic functions, and we call those graphs parabolas. All right, so let me grab another page. Now, one important property of a parabola is that it is symmetrical. So we can fold a parabola so that the two sides match exactly. This property is called symmetry. So the graph of a parabola is symmetrical. One half is exactly like the other half. And the fold, if we fold the parabola in half, I'm going to draw the little pictures that we drew on the other page here again. You already have these, so you can use the ones that you have drawn. I just want them on the same page here. If we fold this parabola, the left side over the right side, they match exactly. Same with this one, if I drew them perfectly. The fold, where we fold it, the line, is called the axis of symmetry. So on both of these parabolas, this, let me do it in red, that, and that would be the axis of symmetry. It goes right through the middle of the parabola. Sometimes we shorthand axis of symmetry and we just call it the axis of the parabola. Now, another important property of parabolas is we have this point here or this point here. Parabolas have a lowest point or a highest point. I'm going to say the lowest or the highest point of a parabola is called the vertex. So this point is the vertex, and this point is the vertex. And every parabola is going to have a vertex. So every parabola has an axis of symmetry, and every parabola has a vertex, the lowest point or a highest point. All right, we good so far? Yes?
Why is the lowest point of the vertex at the very bottom of the line?
One more time.
Why is it the lowest point of the vertex at like the very bottom?
So the graph is the U shape. So the lowest point here is the vertex, or the highest point. On this graph, the parabolas don't have a lowest and a highest point. If they open up, they have a lowest point. If they open down, they have a highest point. Is that what you mean? Of the U shape. The lowest point of the U shape is the vertex. Or if the parabola is upside down, the highest point of the U shape is the vertex. All right, let me grab some more pages, and then we'll go to the other side. There's some more lines, I mean. All right, so for our parabola, let's stop talking, please, folks. For our parabola, if we have an equation, y equals ax squared plus bx plus c. If a, the number in front of x squared, is positive, so if a is greater than 0, the parabola opens up. So if the number in front of x squared is positive, our parabola opens up. It makes a U shape that opens up. And the vertex is a minimum. That means the lowest point. So I'll go back to our picture here in just a second. For this parabola, the equation of this parabola would have the x squared part positive. So it opens up, and the vertex is this lowest point on the U shape. That's the minimum of the graph, the lowest point, the smallest y value. If a is negative, a less than 0, the parabola opens down. and the vertex is a maximum, or the highest point. So when we have an upside down parabola, opening down, that means the number in front of x squared is negative, and that means our vertex is at the very top of that upside down U shape. And that would be this picture. Here, whatever the x squared part was would be negative. That means our parabola opens down, and the vertex is up here at the very top. Now our homework today is going to be all about graphing these quadratic functions. So for graphing, what we're going to do, until we learn a few tricks, for graphing, we're going to make a table of values, just like we've done for other functions. Make a table of values, and we can reflect over the axis. So we can just graph half the parabola, and then we know that it's symmetrical, so we can just make the other half look exactly the same. All right, so let's turn, now we're on the second page. We're going to look at a couple of graphs. Everybody good with our vocabulary? Yes.
What does that word say, like, right after reflect?
Over.
And what is the one above? The graph of quadratic functions.
Make a table. In general, if we're not sure how to graph something, we make a table of values. All right, so we're good with the vocabulary. All right, so let's look at that example on the next page. So it asks us, what is the vertex of this graph? So everybody think about that for a second. Come up with an answer. What is the vertex of this graph of this parabola? Here, I'll trace it in red here so we can see it a little better. There's our parabola. It says, what is the vertex, and is it a maximum or a minimum? So everybody think about that. Come up with your, the vertex is going to, the vertex, what you're looking for is a coordinate, an x and a y. All right, everybody have something? So what point do we think the vertex is where the vertex is located? -2. So we're going over here to -2 and 5 up there. So the vertex is at -2, 5. Is that a maximum or a minimum?
Maximum.
It's a maximum. It's at the top. Ms. Ingram, maybe you know, do they talk about parabolas in physical science? No, you don't?
Eventually, they will here in a little bit because they do that marshmallow catapult.
Well, they used to. They're not doing it this year.
Oh, they're not?
No.
Okay.
So it turns out that if you throw a ball in the air, the path that it takes is a parabola. If you throw something off the side of a building, the shape it takes is half a parabola. So parabolas describe how things move close to the surface of the Earth. And we're going to talk about that quite a bit over the course of the unit. And at the end of the unit, we're going to do a kind of an exploration, a lab, that has to do with coming up with a model of a function that describes something flying through the air. All right, let's look at another example. Next we're going to construct a graph of the function. And this is going to be what most of your homework is like, is making graphs of these quadratic functions. There might be some questions about the vertex, whether the parabola opens up or opens down. All right, so we're going to graph this function by making a table of values. And we're going to graph -2, -1, 0, 1, and 2. If you need to make a table of values, unless it tells you otherwise, these would be the points that you would always choose for your x values. -2, -1, 0, 1, 2. So let's think about this graph for a second. Is this graph going to open up or down? This number in front of the x squared is positive. So we know our parabola is going to open up. So we already know that about our parabola. So to make our table of values, we'll plug in -2 here. 1/2 times -2 squared. Well, that's 1/2 of -2 squared is -2 times -2, which is +4. And 1/2 of 4 is 2. So we're going to have one point at -2, 2. Plug in -1. 1/2 of -1 squared. -1 squared is -1 times -1, which is +1. And 1/2 of +1 is 1/2. So my y value is going to be -1, 1/2. Plug in 0. 1/2 of 0 squared. Well, 0 squared is 0 times 1/2 is 0. So we get a point at 0, 0. Now we'll plug in +1. 1/2 of 1 squared. 1 squared is 1. 1/2 of 1 is 1/2. So we get a point at 1, 1/2. Anyone want to guess what we're going to get when we plug in 2? 2. We have this nice symmetry, and we can see that we're starting this reflection here. And if you're not sure, we'd plug 2 in. 1/2 of 4 is 2. So my graph, I'm going to continue it. This is a nice smooth graph. And there would be a graph of that parabola. The vertex, because it opens up, the vertex is a minimum. And we can see that the y-axis is our axis of symmetry. The vertex is at 0, 0. If they ask where is the vertex? The domain of this function, I can plug any x value in here, and I don't end up with a problem. I'm not dividing by 0 or taking the square root of a negative. So the domain is all real numbers. The range. The range is the y value when we're talking about functions. Well, what's the lowest y value that we get here? 0. So the range is going to be from 0. Well, this keeps going up and up and up on either side. So the range is going to be 0 to infinity. Yes?
What does that say next to the domains?
All real numbers.
Okay,
So in general, when you're making a graph of a parabola, of a quadratic function, make a table of values, plug in numbers, plot your points, and make a smooth graph. Now next time, on Monday, we'll talk a little bit more about graphing these things. And we'll talk about exactly what does changing this number in front of the x squared do. And what happens to our graph if we start adding something with x, adding something, just a number outside. How does that change our function? But for now, we're just talking about basic vocabulary and how do we sketch a graph using a table of values. Any questions?